We are live now. So, hey folks, this is me, Vishwas Nayan. I'm the host of this Bill Piper show. A lot of times I've had this doubt like, where is this monitoring going to take us to? I was like, what should be our right approach in order to get the right solution for our entire CI CD hassle that we have in the production? I think Mahesh sir is one of those people in the industry who's working more towards the DevOps aspect, as well as the cultural shift that is happening in the world of DevOps. I think he's here to educate you folks with respect to all these uh, topics of observability, monitoring, you name it, which is required for your production's health, is there for you. And thank you so much, sir, for being on the show. Means a lot.
Thank you, Vishwas, for the wonderful opportunity here. Hey, folks, good morning, good evening, good afternoon, based on where you're watching this live from. Today, I'm going to be talking about microservices, monitoring, observability in the modern world. I'll try to keep it, really, really very, very simple. After the presentation, I'll have a quick demo using some of the industry tools on how you could monitor, how you could have observability that could help help with your distributed architecture and microservice based architecture. So with that, we'll jump right into the first slide. All right, monolithic architecture, right? So I'm sure many of you might have heard about different types of architecture like monolith, microservices, event driven, and many more, right? So let's quickly understand what is a monolithic architecture and what are the pros and cons of monolithic architecture. Uh, so monolithic architecture, as you can see in this slide, right? I mean, if we take an example of e-commerce application, right? So e-commerce application would consist of many modules, many features, like you for example take Amazon, Flipkart, or Walmart, or any e-commerce, right? So you log in, you search for some product, you add them to the cart, you complete the payment, you provide your address and everything, right? I mean, that's the typical flow, right? So all the modules like searching for a product, adding a product to the cart, payment, user profile, right? So everything kind of gets bundled up when we are building and deploying into one war file, right? I mean, that's more a simplistic way of explaining what a monolithic architecture could be, right? So you bundle everything instead of war or jar file, so that that becomes very very easier for you to deploy it, right? So that's how a monolithic architecture would look like. I mean, you'd have client or end customers hitting a load balancer, and a load balancer, hitting the app deployed on Tomcat or WebLogic, and yeah, and beyond the scenes, you might have some backend servers, database like Oracle, Postgre, or SQL Server that might be completing the architecture. So that's the typical monolithic architecture in a simple way to explain, right? Monolithic architecture, they are simple to develop. I mean, you start working as a simple executable. It's pretty straightforward. I mean, especially when you're beginning with a new project, that might be easier for you to start as a monolith. But as you progress, complexity do arise with monolithic architecture. Like I mentioned, it's a simple deployable var file, right? I mean, all the modules packaged into one var. You put it in Tomcat or with Logic containers, and boom, you would have the application up and running, right? And also sometimes it's easier to scale. I mean, you can scale it horizontally by creating multiple replicas of those Tomcats and WebLogic, and run it behind a load balancer. It's easy to test because you have one simple UI, and you have one simple application where you want to configure all the monitoring, logging, and everything, right? So that becomes simpler, right? And also it's less complex and overhead, without having additional cost of all the intercommunication communication that you need to take care of, right? I mean, sometimes if we have a lot of different moving parts across the architecture, there'll be a lot of integration points that you need to take care of, service discovery, distributed logging, load balancing, and those kind of things. You don't have to worry about, right? So that makes it less complex when you're dealing with monolithic architecture. There are definitely disadvantages. For example, they're all tightly coupled, right? I mean, all these modules are so tightly coupled. So for example, right, if you have a high footprint of payments where you want to scale payment service alone, that might not be possible because everything is packaged. So if you want to scale up and down, you'll have to scale the entire thing, right? I mean, that's one of the biggest disadvantage with this, right? And also it's hard with sometimes hard with CI/CD build and release cycles, right? Because there's a lot of dependencies, right? I mean, all the developers working together have to ensure everything gets packaged at the same time, everything gets deployed at the same time. So it's hard, having to deal with the faster delivery cycle, CI/CD, and the DevOps kind of a culture, right? So. And also big monolithic code base, it's kind of overwhelming for developers. If somebody wants to load on their IDE, it's kind of difficult. Continuous deployment is difficult. Scaling is, of course, one of the biggest challenge. Maintenance also tends to get challenging over a course of time. And over a period of time, the size of the application also can slow down the actual startup time and the overall performance of the application. And lastly, if you want to make some changes and redeploy, you have to redeploy the whole thing, right? So that's a big pain in the neck, right? So and also, you will be attached to one technology stack. I mean, you would not really have a lot of flexibility changing the technology stack with Monolith. So, yeah, that's about, Monolith, right? I mean, I hope this gave an good picture about, what is Monolith, what are the different advantages and disadvantages, and with that, let's move on to the next slide, which talks about microservices, right? So, what's a microservice architecture, and how is it different from monolith-based architecture? So microservice based architecture is different compared to monolith based architecture, compared to the previous slide, right? Here in a in a microservice based architecture, we have each services running autonomously. I mean, each services, it runs on its own. For example, placing an order is a microservices, carting is a microservice, payment. So likewise, microservices are categorized and built, based on certain criteria, right? So they're all autonomous, they're all flexible, right? And there are a lot of pros and cons in microservice architecture as well, right? For example, it helps with continuous delivery and deployment. There is improved maintainability. There is also better testability with each of the microservices, and deployment is a breeze because you can choose to deploy each of the microservices as and when the demand arises, or as and when your requirement needs it, right? So you are free. Like, for example, if you want to make some changes to the item search and deploy it, go ahead. We could do that. Just deploy changes to the item search, right? Whereas in monolith, you had to package the entire thing and redeploy it, right? So here, item search, getting changes and redeployed would not really affect the entire, entire, downtime or entire application, right? So that's one of the biggest, advantage. It also eases development efforts because you'll be able to build autonomous team who will work on these each of the microservices. There is less and less of dependency, right? And also it's easier for developers to understand, so that they don't have to start reading the big code base, right, when they start off with, right? For example, if somebody is working on item search, they can start reading, learning about the item search. It becomes pretty easier compared to getting accustomed to a bigger code base, right? Also, the application start time, performance are also improvised. It also helps us with faster fault isolation, right? For example, if there is a memory leak in one of the service, right? So it doesn't bring down the entire system, right? I mean, yeah, item search. If item search has a memory leak, it might impact the item search, but still other services are going to perform well to the extent how we might be envisioning, right? Whereas in monolith, it could bring down the entire system down, right? So that's another advantage. Other advantage. Also, in microservices, like I said, carting, right? I mean, if you want to bump up CPU memory on a carting service, you could do that, right? Compared to payment. For example, there could be a requirement where footprint might be higher for payment microservices compared to carting microservices, right? So you could independently scale in and scale out the payment services compared to the carting service, right? So likewise, these are some of the advantage of microservices. And also, you don't have to commit to a particular technology stack, right? I mean, one microservice could be built in Node, another could be built in Java, another could be built on Python, right? It's a completely pure polyglot, right? So that's another advantage with microservices. So and also CI/CD, DevOps, everything goes well with the microservice-based architecture. Coming to drawbacks of microservice-based architecture is, I mean, there are a lot of moving parts. There are a lot of integration. Inter-service communication needs to be taken care, and they have to be tested well. Testability also becomes an overhead. Setting up everything. Monitoring. And that's hard. I mean, it's easier in some aspects, but as in when we start building more and more microservices, right? Hundreds of microservices, distributed architecture, that becomes very, very hard to, track a lot of things, right? Testing, implementing becomes, very difficult. Uh, and also, there might, like I mentioned, footprint would vary from microservice to microservices, right? So, and also testing would also become a little complicated with a lot of moving parts. So, yeah, to sum up, microservice based architecture is different compared to monolith, but there are pros and cons with microservice based architecture as well. So you understood. I hope you understood. What is a monolith? What is microservice? What are the pros and cons of each of the architecture? So I'm going to talk about now. Uh, when do you decide when do you decide which architecture to use? I mean, when do you have to use monolith, when do you have to use microservices, and when do you have to migrate or transition from monolith to microservices, right? There is no right and answer, right? I mean, whether microservice is the best or the monolith is the best, right? I mean, lot of people are under the assumption that the way forward is microservice based architecture. The monolith is going to be completely replaced by microservice based architecture, which is absolutely not true, right? So it depends on it depends on your own requirements. It depends on requirements. It varies from company to company what their requirements are, what they are trying to achieve, right? I mean, as an architect, right? I mean, we have to decide depending on what role you are playing, right? I mean, you'll have to work with architects, or architects, majorly get to play a vital role in terms of deciding, whether one has to go with microservice-based architecture or monolith-based architecture, right? I have, seen a lot of projects and companies where they have they started with monolith, migrated to microservices, and came back to monolith architecture, right? It's not, I mean, there is no single answer. It's neither I mean, it's not that you always have to choose microservice based architecture, right? I mean, again, like you said, it depends. I mean, you need to identify the trade-off between each of them, and then depending on the requirements, you need to choose, right? Yeah, like I said, microservice is not just the future. I mean, a lot of companies have chosen to go back to monolith, right? So when you have to choose, monolith, I mean, you'll it's advisable. I mean, some of the recommendation to be to go forward with monolith is, when team is starting newly, for something that they want to build quickly and showcase and get some buy-ins, right? So small teams, monolith works great. When you have data integrity and strong consistency requirements, monolith might be great. uh, you know uh, Monolith application may cost more as it grow, but they are like cost effective and faster to create in a very beginning, right? And also, when your team does not have a lot of experience with various technology and tool stack, when they don't have a lot of experience with distributed architecture and microservices, monolith might be the best thing to do. Microservices, when you have bigger teams, when you have dedicated team to work and manage the microservices, that's when you need to be going with microservices. When you have to build more independent feature, when there are requirements where each of the services your module have their own scalability, compliance, SLAs, and availability requirements, then it might be feasible to go with the microservices. When there are a lot of changes, right, for a particular domain or module, that might be uh, one of the requirements where you might have to go with the microservices. Microservices would also have operational overhead. Uh, yeah, see, these are some of the ground rules on whether you should be choosing microservices or monolith, right? Uh, but yeah, bottom line, try to understand, when to use monolith versus when to use microservices. Traditional monolith architecture are, hard to scale, compared to microservices. Microservices have the polyglot advantage where you could use, different technology stack, right? And also when speed, right? I mean, when you are working with CI/CD deliveries, DevOps, and the speed, you have to keep up with the speed. Microservice architecture works great. I mean, they also create a very efficient team, right? I mean, as an organization is growing, or if you're planning to grow your team with enterprise application, it's advisable to go with microservices. Uh, yeah, bottom line, the key takeaway from this slide is there's no hard and fast rule that you have to be choosing microservices and monolith. Depending on your requirements, depending on your needs, architects have to work and take the best decision here. So this is one of the slide I picked up from InfoQ, where it talks about still modular monolith is being used by the early majority. A lot of companies and a lot of projects are heavily using monolith. Uh, I'm going to quickly talk about how one can move from monolith to microservices. How does one make the transition happen, right? When we are decoupling a monolith, or when we are moving from monolith to microservice based architecture, a couple of things to keep in mind is, avoid refactoring everything at once. I mean, don't plan in such a way that you're going to refactor and replace everything at once. I mean, that's a bad strategy, right? Uh, and and also you have to incrementally migrate the services. I mean, you have to build one by one, migrate one by one, so that that becomes an easier path to go, right? And also, services in microservice architecture are concerned about organized around business concerns, and not really a lot of times in the technical concerns, right? So that's another thing to keep in mind. So decomposing monoliths. So there are certain strategies that's been used. So the first one is the business capability, right? So you could break down when you are migrating from monolith to microservices. A monolith can be decomposed by using organizations' business capabilities. For example, you could have sales, marketing, customer service, and other departments, other business capabilities. by which you're going to break down the services, right? So sales would become one business capability where you're going to be developing some services, and likewise for marketing, right? The next one, decomposed by subdomain. So once you have the high level business capabilities defined, you could break it down into subdomain. Uh, Using, like, for example, sales could be broken down into purchasing, claims. Marketing could be broken down into campaign analytics reports. So they all become the microservices, right? Which where we are going to be decomposing by subdomain. So have the domain break down depending on the business capability, break it down depending on the subdomain, right? The third one, you could also decompose by, transaction, right? I mean, in distributed architecture, there'll be a multiple calls and multiple transaction that has to happen to complete one user flow or one business transaction, right? So the whole thing could be one microservice, right? You could break it down, depending on that, right? That would alleviate a lot of, latency and other, problems. I mean, especially if you are really concerned about response time, that's when you have to be using the decomposition by transactions. Services per team pattern. I mean, this is a pattern where each team would own one microservices. So instead of decomposing by business
Can
of
you take the
dimension.
questions now only?
I'm
Can you
sorry.
take the questions now only? Can you take the questions now only if you are okay with it? Like there are some two questions which are there.
Yeah.
Sure. So, how can you break single application exe into multiple services?
How can we break similar exe into multiple microservices?
Single application exe into multiple microservice.
Uh, yeah, I mean that's what I said. I mean, for example, right? I mean, if your one exe contains, multiple modules, right? Like, for example, if you are packaging one exe with sales, marketing, and other domains, either break it by domain or break it by transaction, or break it by one service that one team can own. I mean, you will have to look at what your requirements are. You will have to look at some of the ground rules I explained. Based on that, you can break it down. But one advice is, don't try to move everything in the exe to microservices, but rather take an incremental approach. Like, I'm going to talk about one particular strategy to be used, which is called the Strangler Approach. I'll talk about that in a bit. But don't make the move. I mean, don't make the complete move. Do an incremental approach depending on your requirements, and move it along so that you have microservices working on the same lines as the exe. Hope that answers your question. Should I move forward, Vishwas? Hello? Vishwas, I cannot hear you. Should I move forward?
Sure, sure. You can move ahead, sir. You can move ahead. Sure, that would be great.
I should move forward?
Yes, sir.
Okay, thank you. All right. So integrating microservices, I'll quickly talk about that. So we have certain ways to integrate microservices. One is the API gateway. So API gateway is an as a service which has a lot of capabilities where it helps you to integrate microservices. It helps you to throttle the request. It will help. It has capabilities like circuit breaker. It can help with authorization, authentication. So basically, to combine all the requests, API gateway is one of the patterns, right? Decoupling message pattern is another pattern to integrate microservices, where it's an asynchronous Paul model, where you decouple you decouple and quickly consolidate such a way that it works together. Like for example, right, we have something called Amazon queuing service. So what it does is it takes from one microservices and puts in the queue, so that the other microservices can pick up from there. So basically we are trying to decouple the messaging pattern so that we can try to integrate the microservices as a whole. The publisher subscriber integrating microservices in other platform where we have publishers and subscribers. Like for example, there could be some microservices which would publish it could be the notifications or publish something else so that other subscribing services or microservices could take that out. I mean, could subscribe and take that message out or information out, so that way the transaction or the user flow is completed. uh, Talking about data persistence, I'll quickly touch upon few ways for data persistence. So when you're building microservice-based architecture, so there could be database per service. I mean, each service could have its own database. For example, one service could have DynamoDB, another service could have Oracle, another service could have Aurora, PG, or other things, right? So again, depending on the needs, there could be one database for multiple services or one database for each of the services, right? API composition pattern where it's a composition pattern where we would have an API composer which would take inputs from one microservices, from multiple microservices and consolidate that, and it helps you to join it in memory, so that way the messaging, the flow can be taken care. Cqrs pattern, it's the command query responsibility segregation pattern where you're going to segregate all the reads and writes, right? So you would have reads going to one data source and all the writes going to another data source. So lastly, the Shaka pattern, it goes along with Cqrs pattern. So let's imagine that you're building an e-commerce store where customer have a credit limit, right? So you have to ensure that new order will not exceed the customer credit limit, right? But orders and customers are both different microservices or both different database owned. You cannot simply do an local ACID transactions and confirm it, right? So that's where Shaka comes into picture. Shaka helps you to consolidate and run that local ACID that's needed, right? Yeah, this is all about how do one decompose monolith to microservices, and what are the different strategies and patterns that could help us out here. Moving on to next slide. So this is one of the distributed architecture slide. So you could imagine, this might be a little overwhelming, right? When you look at this slide, right? I mean, this could be 100 times complex. This could be 100 times more, or 100 or 1,000 times more in terms of architecture when we are building microservice-based architecture, right? If you quickly look at here, you have client, hitting Route 53, coming to WAF, talking to ELB, and you have scaling, you have two availability zone, there is Kubernetes cluster, you have databases running on each of the availability zone, there is caching, there is replicas to take care, right? I mean, if you look at here, right, I mean, you can understand how complex it's going to get with microservices, right? Especially when you are integrating, when you have to find some problem, right, in this slide, right, in one of the component, if something fails, and if you have to figure out why it failed, where it failed, how it failed, that can be pretty daunting, right? So observability and monitoring is definitely key when it comes to microservices, because the complexity can grow as you start building more and more services, right? So you need to have a good observability and monitoring to report on the overall health of the system, the overall state, what's being experienced by the customers, what are the key things to monitor, what are the tooling that you would need to debug your system in the production environment, right? So yeah. uh, Okay, monitoring microservices. I kind of touched up in the earlier slide. Why is it important to monitor microservices, right? Before that, one particular approach I'm going to be I want to touch upon when we are migrating from monolith to microservices is the Sprangler approach. So Strangler approach is where when you are moving from monolith to microservices, you'll start you'll start migrating services one by one, right? So that way that the microservices would become more and more, and they kind of strangle the whole thing, the whole microservices, so that the microservices sorry, the monolith might become obsolete at one point, and microservices could take over, right? So strangler approach is one of the popular approach that's being followed when you are moving from monolith to microservices. All right. So coming back to monitoring microservices, why is it important, right? The CTO of Amazon had said, everything will eventually fail. Everything will eventually fail over time, right? So you cannot guarantee, right? I mean, even AWS components on AWS can fail. I mean, they also have downtimes, right? So everything can fail. In a distributed system, it's important to know, what failed, where it failed, how it failed, when it failed, right? So that's very important, right? And also, failure is not the obvious reason why monitoring is important, because system performance is going to degrade over a period of time. It's not that you deploy it today and every time that it's going to fail the next second, right? So system are going to degrade over a period of time, and it's important to monitor the system, right? Why is it degrading, what are the causes of degrading, and so that you can start finding the root cause and start fixing the root cause why it caused, right? Monitoring system is also important because you will also have I mean that's dependent on your customer success, product success, and everything, right? Because you will have certain amount of service level agreement with customers, and you will have to honor that, right? You will have to live up to that, right? So monitoring is extremely important to honor that, right? And also sometimes it will help you to analyze the pattern. It will help you to look at the patterns. For example, there could be uh, uh, there could be many times where you do a CI/CD, and a lot of times something fails, right? So that would only tell you that the code that you are pushing into the production environment or any other environment has a problem, right? So fix something with a CI/CD. It could be do a lot more testing, lot more code reviews, and whatnot, right? And also maintaining a system. I mean, monitoring is important to maintain a system, right? Should be to make it a resilient, to meet the customer expectations and whatnot, right? So there are a lot of other reasons why monitoring is important, but these are some of the very important reasons why monitoring is extremely important. uh, Observability, right? I mean, what is observability? It's the latest buzzword, I would say. Even when we were doing observability 8 10 years back, right? I mean, even though we were doing observability, we didn't actually know that it was called observability. I mean, that's how all the buzzwords come up and go away, right? So yeah, so for many people, observability would definitely mean a lot of different things. I mean, if you ask a architect, he might tell one meaning for observability, likewise for a developer, likewise for product management and whatnot, right? So observable definitely means a lot of things for different people, right? I mean, in a simple terms, right? Observability is all about bringing better visibility into the things, right? I mean, it's finding unknowns of unknowns, right? I mean, observability is all about driving customer success, figuring out what is going wrong in your system, quickly able to isolate the problem, quickly able to help SREs or whoever to fix that problem, right? So uh, So observability is all about bringing better visibility into the system, right? So a lot of people talk about the three pillars, and I'm going to be touching upon that in the next slide, where logs, metrics, traces are the pillars of observability, right? So observability, like I said, it's all about it's all about bringing good visibility into the system, so that you could debug, you could fix, you could isolate problems, and observability is just not a SRE problem or operation teams concerns or whatnot, right? I mean, you have to work the whole product management, R&D, and everybody involved, right? They all have to work together in building an observable system, right? I mean, it's not that you build something, dump it on operations team, and ask them to make it observable, right? I mean, that's not the way it works, right? You'll just not have an observable system by just having monitoring in place. I mean, that would not really help you, right? So observability is about where you can make some key decisions. You'll be able to roll back. If something. I mean, the observability is about a system which can tell you when you have to roll back, why you have to roll back. Observability is also about testing and ensuring you have the ability to look what's happening in the system, right? uh so yeah, that's more on observability to define in a simple terms. I mean, like I said, it's all about understanding why is your system having problem, is it fast or slow, what are the KPIs, SLAs you need to be looking at, right? So that's more of observability. So what's difference between monitoring and observability? Monitoring is something which allows team to watch and understand the current state of the system, right? I mean, for example, if you look at a CPU graph and if it's spiking up, right, so you could tell that something is going wrong. The CPU is going up to 90, 100%, right? So monitoring is based on certain predefined metrics and logs, right? I mean, you would predefine CPU, would predefine disk, would predefine something else, so that you could look at the current state of the system. That's monitoring. Whereas observability is all about actively finding the unknowns. I mean, actively debugging the system. I mean, it's like exploding. If something goes wrong, uh, your monitoring cannot really tell you the unknowns. I mean, your monitoring cannot. Your monitoring has some limitations. So observability is about actively debugging the system, exploring, finding the unknowns. Right. That's observability. Uh, Monitoring and observability is not really they're not two different worlds. I mean, they are observability is actually a superset of monitoring. I mean, they have to work together, right? So it's important that they both work in tandem, right? Observability is kind of superset of both monitoring, right? I mean, yeah, that's the key difference between observability and monitoring. The three key pillars, I'll quickly touch upon and move to a demo. I think we're going to be falling short of time, but I'll keep picking up. So logs, traces, and metrics are three important pillars of observability. So log talks about what to investigate. They tell you what you need to look at, right? What to investigate. And metrics talks about when an issue has occurred. Metrics will tell you when an issue has occurred, right? Traces, they'll tell you, they'll help you to identify where the problem is, right? So that's logs, metric, and traces. uh, yeah, I will not get into details of this, but I can take questions if you have anything towards the end. Uh, so I can quickly talk about what is a log. So a log is, as you know, I'm sure everybody know what is a log is. I mean, it's a timestamp, a record of discrete events that could be happening. I mean, it could be printing a lot of things. I mean, with some payload, timestamp, and some context, right? I mean, that's more of log. And metrics is about numerical representation of data over intervals of time. Like for example, response time metric, CPU metric, and other metrics, right? And trace is a representation of distributed events. It completes the end-to-end flow. What exactly happens. What exactly happens between the upstreams and the downstream events, right? How I mean, tracing the entire request is what traceability trace is all about. So, yeah, that's in a nutshell about log metrics and traces. Yeah, quick snippet about what tracing is all about. I mean, tracing is all about tracing the request. For example, if client makes a request, you trace the downstreams and how it's how what kind of calls and what kind of other services is it calling. So traceability is all about connecting those dots. Observability benefits. So I'm going to quickly touch upon three important benefits. So it helps us to understand application health and performance to improve the customer experience, right? So observability helps us with what is going on every anywhere and everywhere in the system, so that you can keep up with your customer experience. It helps you improvise developer and productivity. I mean, a lot of times developers would be scratching their heads, not able to find out, where is it failing? Where is it failing? How can I analyze further, right? I mean, that's a tedious job, and observability can actually help here. Improvise operational efficiency and effectiveness, right? So there'll be, for example, there could be fleet of servers, and there could be some CPU leakage that could be happening, right? Observability could help you to analyze what is happening. It can also help you, predict your further capacity needs and take advantage of the cost, right? It's not limited to these benefits. Certainly there are a lot more benefits with observabilities. Observability solutions. I mean, this let's talk about some tooling and solution what Amazon provides, like Cloudwatch. Cloudwatch is not completely observability; it's more of tracing, alerting. Logging, alerting, and monitoring. X-ray is more of observability, and you also have Code Guru Profiler, DevOps Guru, which helps with observability. So these are a full fleet of AWS what it provides in terms of observability, where you have synthetic, X-ray, RAM. So Code Guru, I'll quickly touch upon Code Guru. So Code Guru is where you'll have to install an agent, configure an agent with your Git repo, whatever. So whenever you check in a code, Code Guru will help you to Code Guru would quickly review the code and provide you recommendation. What is wrong, what is right, what has to be improved. So that way you can catch code problems before they hit your production environment. There's one snippet where Cloud Guru could help you. Like for example, you know, the code written cannot be reused across several invocations of Lambda functions. So it's recommending that you change that. Some exceptions. So Cloud Guru can offer a lot of benefits for you. And DevOps Guru, this is built with ML models where Amazon has used their experience to build this DevOps Code Guru. For example, what it does typically, it's over many years of database experience, they have created knowledge base which uses ML models to tell you collectively, proactively, what has to be taken care. For example, there could be a bottleneck on the database, and even before it could happen, or if it's bound to happen in the next few days, Cloud Guru, DevOps Guru could tell you, what has to be fine tuned, what has to be looked at, what has to be taken care of. So that's about Cloud Guru. Other observability like Datadog, AppDynamics, Dynatrace, all are commercial tools. OpenTelemetry, Prometheus, Grafana, OpenSearch, they all have open source available as well as part of observability. Datadog, they have fleet of services. I'll have a quick demo on Datadog and X-Ray now. All right, I'll stop here and move on to demo now. Just give me 1 second. I'll I'll open up my Okay. All right. I'll share my screen now.
Sure, sir.
Um,
So one quick question, like, what was your first introduction to the room full of people talking DevOps? So what was that all about once you started? I just wanted to ask you this question.
oh, sorry, I missed the last part. Which was, could you repeat for me?
I just wanted to know what was your first experience when you heard a room full of people talking DevOps?
Oh, in this meeting? Every, I mean, DevOps is the latest buzzword, right? I mean, not buzzword. I mean, I would say DevOps is full of opportunity, right? I mean, DevOps is full of opportunity. DevOps is full of a lot of promises, right? I mean, a lot of companies have benefited with DevOps. A lot of companies have been able to build enterprise product and solutions, which is helping millions and billions of people, right? I mean, DevOps is actually helping a lot of lot of industries. It's changing a lot of lives. So there are real time examples. I mean, even during the COVID time, where DevOps has actually helped a lot of companies' products. So DevOps is all about promises, and it has lived up to the expectations.
Sure, let's get started. Let's start with the
All
DevOps.
all right,
Sure, sir. You can go ahead.
can you see my screen with the
Yeah, I
AWS?
can see your screen. Yeah,
Can
yeah,
you
I
see?
am able to see your. I'm able to see your AWS console.
Okay, perfect. All right, so just give me 1 second. Okay, so built an app where there's some simple app, right? So what it does is it's built on a Spring framework where it has an web UI which you are seeing to implement the JSON web API with using AWS Java SDKs, and it talks with DynamoDB to track a lot of things like this is a simple gaming app like the TikTok app. I'm going to log in and show it to you, but it uses like lambda functions to trigger. It uses database as DynamoDB, and we're going to use this app to look at what is monitoring all about, what is tracing all about, and yeah, let's get started. So we let's enter some demo 1 2 3 demo 1 2. I'm going to create a session. So let's call demo 1 2 3, and we're going to play the tic tac game. So let's play the game. So this is the game. So basically, what it does is whenever you make the move, the Lambda invocation is triggered, and also it sends notification to your email once you complete the game and once you win the game, right? So that's a simple app. So I'm gonna do here. Um, so let's do. Okay, so yeah, we have completed the game. So one thing is, I should have gotten some notification that the game is done, but I have not gotten any notification that the game is completed. So that's unless why I did not receive any notification here, right? So if you want to look at first thing is let's look at DynamoDB. Let's look at DynamoDB. Uh, Okay, so this is the score keep game, right? So let's look at the move. If something is odd here, right? So, So read usage seems to be fine. Write usage very limited. Uh, Nothing seems really odd here, right? Nothing really seems very odd here. Likewise, if you want to check the session table, if something is not right here, I don't see anything odd here, right? So yeah, let's look at lambda function that we have for this app. Let's look at. Let's look at 1 second. Uh, yeah, 1 second. Let's look at SMS also. SMS. Yeah, if you look at the topics here, score keep notification, that looks all good. There is nothing off here. So now let's look at X-ray. So what I'm trying to say here is, yeah, you could go look at the different logs and metrics. For example, like you mentioned, you could look at the Lambda, you could look at the DynamoDB tables, you could look at the API request made, right? There might not be anything off for you, right? Because you are not able to really connect the dots. You're really not able to visualize the entire transaction flow here. That's where, observability comes into picture. For example, yeah. Uh, Yeah, if you look at here, if you look at here, right? I mean, this is what is observability, right? I mean, for example, the client. I was the client, right? So I hit the Scorekeep app. When I hit this app, it comes to the Amazon ECS where we have deployed as container. And the container, talk the app in the container talks to different Dynamo TV table like user table, move table, session table, state table, and game table, right? So you could also look at the response distribution, the latency between this and this. It also tells about how many traces per minute that we have been that it's been able to capture. So one way to look at the trace is, come here and, for example, if you want to look at, okay, uh, let's pick up 70 milliseconds for this. Let's analyze the trace for this. So this the trace list. So if we come here, trace list. So this would tell us, this would give us a trace of the entire thing, what happened and why did it happen. Like for example, DynamoDB, it's an update item. So we try to update something in the store keep. You could also look at overview, which talks about the response status. If there are any errors. Table name, what operation did we do? We did an update. So if there are any exceptions, it's going to list down here. Yeah, so let's, yeah, that's the trace. I mean, that's the service map that I was talking about. But let me do another trace. I want to capture another trace. So let's play another game. Let's view the trace for this. Yeah, I'm trying to refresh. Uh, yeah, let's do another trace. Yeah, let's do another trace. So what we'll do is we'll launch a new game again. Uh, create Deco, play, create traces for this game. Yeah, so we have completed this game and expense. Now let's look at trace for this. Okay. Yeah, I think something is off here. Uh, yeah. So if you look at here, right? I mean, again, look at the tracing here. It traces back all the downstream and upstreams. Like how the request is being flown from client to container to SNS, notification service, uh, to different DynamoDB tables, how it's setting, score keep state, score keep move, score keep game. Uh, let's try to introduce an error and look at how do we trace that error, right? So for that, what we're going to do is we're going to go to Cloudformation. We're going to go to Cloudformation. What we'll do is update the stack. Yeah, one thing you noticed is, I didn't get any email, right? I mean, uh, the reason for that is, yeah, let's analyze it. Yeah, if you look at here, right? Why I did not get an email? I mean, that's very hard to figure out, right? I mean, if you are just looking at logs or if you're just looking at metrics, that's hard to figure out. I mean, there's so many integration, there's so many upstreams and downstream request and response that's happening. It's very hard, right? So if you look at I mean, something like this, where the entire system is observable, that will make your job easier. So if I come to the service map and look at here, I could see something is off here, right? So I want to trace back, what is wrong here. So come back here. And if you look at, there is some error, right? So we are able to say something is not good here, something is wrong here. So let's drill it. Let's drill down. So if you want to know exactly what happens, we need to drill down. So view traces. So this is the trace list. We're going to be drilling down. So let's drill it down here. So Uh, okay, so something is failing here. So if we come here, response status is 400. Resource. Okay, exceptions, right? Okay, yeah. Here, if we can look at here, invalid parameter or email address is invalid, right? So that's the reason why it's not able to send it's not able to send notification to my email once the game is completed, right? So it clearly tells you that why it's failing, why the notification is failing, right? So that's the beauty of observability. I mean, that's the beauty of traceability, right? You could literally trace back the request. Where is it failing? Why is it failing, right? So that's about the observability. So let's fix this problem, right? So if we come back here, Cloudformation, where we have the template, where we have the code. Let's click on. Sorry, let's update. So update. We'll update the stack. So one thing you noticed here is, we have not given we are not given a correct email ID. I mean, we just have an update. So let's replace with the correct email ID now. So if I now replace with the correct email ID, and click next, and update the stack. Oh, sorry. Now update the stack. It's running. Let's give it a minute. It should be done. So meanwhile, I'll quickly touch upon other key items here. So if we come back here for okay, let's look at tracing for this view traces. So yeah, your trace list gives you a list of traces. It tells you the method and the response. You could also look at what client IP it's coming from. You could also look at the average response time for the URLs and percentage of traces. I showed you earlier, to drill down to the trace. You could look at how long it's taking. If you want to look at the raw data, what's being done in the under the hood, you can look at here, like it's been communicating with DynamoDB. Uh, let's look at CloudFormation if it's done. The update is still happening, so let's give it another minute. Okay, the update is done. So let's play the game again. So I'll come here. So we will create ABCD12, PTM12. Let's create next game. Chat 123. I'm gonna play a tic-tac-toe game. Let's play a new game, and let's look at this service map. So X. Something is off here. Something is off here. Let me refresh. Okay, so we win the game. So let's look at. No, we have not got any notification. Let's look at why something is wrong. So simple notification service. Something could be off. So, so we come here. Simple notification service. Topic subscription. So we just have to confirm subscription. Sorry, I think I need to confirm subscription. SMS. So have a subscription, confirm subscription. So I had to confirm the subscription. So I'm done confirming the subscription. So I'll refresh the page now. So I think we are good to go. So we'll play another game. We'll play another game. Okay, so playing another game now. Create. Playing another game now. Create. Play. X. O. X. O. X. O. X. Okay, X win. So let's look at the service map. So let's look at if you have got the right notification. I think it might take some time. It will take a bit to get all the traces. But if you look at now, right? I mean, we don't see any error messages. I mean, the notifications should be working fine. If we look at here, I should have got notification. So let me check in spam. Spam be good. Yeah, it will take a bit to really reflect, so it might taking some time. We can also quickly look at another game. So another notification has been sent. Yeah, we got the notification here, right? See winner, right? So yeah, that's about traceability. That's about observability. I mean, we were able to trace down the system. We were able to look at where the problem was. We were able to fix the problem, and then we were able to play the game again. So that we are starting to get the notification, right? So yeah, that's a quick demo, and I can also quickly demo about Datadog. Vishwas, can you see Datadog screen?
Yes, sir. I'm able to see.
You can.
Yes. Yes. Yes.
Okay. Okay. Thank you. All right. So yeah, before that, I'll quickly jump on to another product, my bookstore. Uh, So my bookstore is a simple app where you can come here, purchase the books, you can search for the book, you can add them to the cart, you can check out the cart, you can make the payment, right? So there's a lot of features. I mean, it's a full stack. Sorry, it's a full blown application which has front end, back end, database, serverless. It uses API gateway. Uh, yeah, it's it uses Cognito. It uses CDN like Amazon, CloudFront. It has Elasticsearch. It uses Redis Cache, right? So we'll quickly, play around and look at some monitors, dashboards in the Datadog and how it looks like in terms of observability. Uh, so imagine that okay, I've already logged in and I'm going to be purchasing few books on database. Add to cart, add to cart, add to cart, add to cart. So I'm done adding to the cart. uh, I'll come here, check out credit card number details. I'll make the payment here. Your purchased. It says purchase is complete. I'm gonna review it. Yeah, it shows the past purchase that we have done. I can also search for books here. Uh, no results. I can also look at bestsellers, top 20 bestsellers, past orders. You can also come and look at the past orders. Okay, so yeah, we have done some activity now. Let's look at Datadog. So Datadog is another industry leading observability tool. It has a lot of capabilities, features. I mean, it's an enterprise edition tool, right? I'll quickly run through, touch upon few key features and capabilities what Datadog has, and then we can open it up for Q&A. So Datadog, like I spoke about Cloudwatch and other monitoring tools. It can monitor your infrastructure, like for example serverless, right? Since we have a lot of lambda serverless functions that are running, so you can come here and look at the serverless functions, like how many invocations, how long it's been running, what's the errors and things like that, right? So you could literally build a host map to monitor everything. See, these are some of the hosts that I can monitor. This belongs to one region, there's another region, so you could click here. You could drill down on all these hosts, right? It can monitor containers, queue, network mapping, and a lot of other things, right? And you could also build dashboard list. Let me show you some dashboard list here. Yeah, AWS Lambda. So if you look at here, my bookstore, right? So my bookstore. So these are the max execution time of some of the Lambda functions. So my bookstore that we the application that we use to search books and order some books. So there's a Lambda function which is taking a lot of time here. So you could come here, look at this. Dashboard to understand execution time, if it has any cold start problems, what's the concurrency, how many functions have been invoked here. You could also drill down into this, in terms of viewing related functions. uh, there are other I mean, you could literally build a lot of dashboards here. For example, DynamoDB, another example, DynamoDB. If you look at, you could come and look at the tables. What are the latency for the different tables that we have here. You could look at the write consumed, how many writes have been consumed by the DynamoDB, how many reads have been consumed by the DynamoDB. Right, this is all for the My Bookstore app that we did a while ago. Uh, you can also look at Elastic Cache. I mean, we are also using Elastic Cache, which is the memcache that we are using. So this shows, how many connections has happened for the clusters. What's the CPU utilization of the memcache? Network incoming bytes. Uh, what's the swap usage for the memcache memory that we have, right? Another example is looking at API gateway. So API gateway, you could look at, what's the total request count, what's the latency, total API by error rate. I mean, my bookstore, if there are any APIs. Yeah, if you look at here, 2.16, my bookstore API is one of the slowest ones. So you could, drill down, look at the traces, request count again. Yeah, a lot of information that it can provide. And another look at his the EC2. Yeah, the EC2. How many instances? What's the current status of the instance? How many instances have been running on this cluster? It's state to micro, large. memory usage, CPU usage, how many credits to have, network, what is the network instance ID, total network out, throttling, so a lot of details. Also, this the APM where it provides tracing service map that we saw on the X-ray. It's similar to that, and integration. It can literally integrate to a lot of different third parties. Including Amazon and others in the marketplace. It also works on agent where you deploy agent. For example, if you want to monitor an EC2 instance, you deploy an agent on EC2 instance, hook it up, and start monitoring. And also, it has out of the box integration for a lot of them. It also has logging pattern where you could, tail it live. You could do analytics built out of the logs. A lot of capabilities with logging as well. I mean, another very important capabilities of Datadog is the synthetic monitoring, where you could build your browser test or API test and run it on your live production environment to start monitoring. How is your system behaving? Is it slow? Is it fast? If there are any problems, you could build, like, for example, this one UI test where I have built, and you could run it with like every hour, every day, or with whatever frequency you want, and it could also provide you snapshots, and it could also provide you details of the test runs, right? And you could also run from any location. For example, if you have an app deployed in India, and if you want to look at how much slow it is if somebody is accessing from Australia or Middle East, you can run it from that location as well. If you look at here, it's running from California, Ireland, Hong Kong, London, and different other location. And also, it's telling how long it's taking, right? Uh, and also you could use it as part of your CI. I mean, a lot of times the problem that we have when we run test automation and other things, right? When test automation, there are a lot of tests which has flakiness built in, right? So Datadog CI integration which will provide a better observability in terms of helping you understand where the problems are, why is it flaky, what do you need to do to fix the flakiness, and whatnot. uh, it also provides security features. Yeah, I think that's about. I'll switch back to my PPT. Just give me 1 second. Yeah, lastly, credits to Presentigo for the PPT and images, and Amazon Web Services, and Illusion and Team. About me, my name is, sorry, I forgot to introduce in the very beginning. I usually tend to do in the end. So my name is Mahesh Mallikarjunayya. I have been working in the industry for the last 20 years. I have built many engineering teams from scratch. I have experience as engineering leader. I've been involved in a lot of projects. Projects like projects where we have moved legacy based architecture products to more modernized based architecture products. Have been heavily involved in a cloud journey where we have migrated our customers from on-premise to cloud. Been part of DevOps, SaaS, been part of quality. Uh, yeah, that's about it. I think, which was, I think I'm done here. We can open it up for Q&A.
Sure. I think, to be very frank with you, I'm so honored that I called you for this Piper show, because it's a real time production issue that you solved right now in front of us. And I'm really glad that I was able to call you for this session. And I think, yes, of course, there are a lot of questions. I think Alexandra Boyka is asking about, aren't logs at races the same thing?
No, logs and traces are not the same thing. Uh, See, logs, it's going to print the timestamp, context, what, for example, right? I mean, it can print a number, right? CPU 80%, CPU 90%, but you cannot really go beyond that, right? I mean, you need to understand why is it 80%, why is it 90%, why is it 100%. That's where traces help you, right? Traces connects the entire flow from UI, middle tier, backend, database, upstream, downstream. It connects everything, right? So it gives an entire visualization, like I showed you on the service map. It gives you an entire picture, right? So that way you can drill it down to understand, why something failed, why, where it failed, how it failed, and everything, right? So logs definitely they are helpful, but logs and traces are definitely two different things.
Sure. I think Nukur is asking about any reason why it didn't get captured in the X-ray, like the error which you faced, and also the subscription issues.
It got captured, right? I mean, initially it was taking bit of a time to reflect in the X-ray, but later on we saw that the yellow mark that was highlighted for the SNS, where it was stating that there is some problem with the SNS, it's not able to send the notification, right? So that's where we were able to drill it down and look at the error message that the email ID is invalid, right? So that's when I went back to my template, gave a correct email ID, rebuilt and redeployed it. And that's when it started sending notification to my email. I also showed you the email where I got an email message stating that I completed the game and I own the game, right? So yeah.
Yeah, I think most of the things were already asked even in the beginning. So I think I've lost the LinkedIn messages, but I think the one other question was, I'll just get back to the LinkedIn because it's a little bit done because I don't know why the network was so bad today. So yes. So I think Jitendra is asking about how can we break into a single application EXE. That is answered. Can you please explain a bit more about how to break down based on the transaction?
Yeah, based on the transaction, right? I mean, for example, right? If a particular, I'll take a banking example, right? So in a banking example, right, fund transfer might be one transaction which is extremely important, which could be extremely important, right? Compared to other transaction like checking the balance or other transaction, right? So if fund transfer, if you think is extremely important for you, have a microservices built for fund transfer and have a team that could manage the fund transfer transaction for you, right? So that way, you take the microservices team takes care of the fund transfer transaction so that they have control of the entire fund transaction microservices. So that gets the highest important. That gets everything that you need to succeed, right? So that's a simple example of what I was talking about, break it down by transaction. I mean, look at the transaction, what are important. Look at transaction, what transaction performance are important, what transactions are important from customer success standpoint, what transactions are important from business standpoint, right? So based on that, try to break it down and have it separate microservices and team to manage that.
Sure, I think looks like Datadog is much more better than AWS X-ray. Any reason to use AWS X-ray? So this is the question.
Looks like Datadog is much better than Edge. Any reason to prefer use AWS X-Ray? Yeah, Datadog definitely is an enterprise edition tool. It has a lot of capabilities. It can offer much more than AWS X-Ray. But the reason I wanted to show both the solutions is, when you are working on AWS, right? I mean, some of them might feel very easier to do with X-ray, given that it has closed net integration. AWS would of course has a lot of good integration among their services, like for example Lambda invocations, API gateway, DynamoDB, and a lot of other things. And also it has something called AWS step in, which would kind of build a flow chart along with your AWS X-ray, right? Yeah, so there are reasons why AWS X-ray might be preferred. Depending on how heavily you are into AWS compared to Datadog. But Datadog definitely offers a lot more than X-ray. I mean, like I showed you, Datadog not just offers you traceability APM, but it also offers you a lot of synthetic testing, CI validations. It has a lot more capabilities. So depending on your need and requirements, do pick one of them. But AWS X-ray definitely seems lightweight and lightweight compared to Datadog. So perhaps you can start with X-ray and slowly branch it out to Datadog depending on your needs.
Sure. I think it's more than whatever we had expected. It took more time. I think that's thanks to those demos, which I really felt so glad that I want Mahesh sir on the show. And also, trust me, I think probably he's going to be there in the DevOps Champion interview as well. So we are doing the DevOps Champion interview. Of course, he's coming on my channel. So as a podcast guest, so it's an honor to have him anywhere digitally and get the knowledge, even physical events. Yes, we are planning for that. We'll be coming in for that events for sure. And I think if you have any queries, questions, do reach out to him on LinkedIn, Twitter, wherever you can find him. I think he's very active on social media, so he'll be able to help you out.
Sure, anytime.
Sure, then let's end the broadcast, folks. Thank you so much. This is Vishwas Nayan, community advocate from Obsti, signing off right now.
Thanks